All right, chemistry family, welcome to the initial introduction to single replacement reactions. We've learned about quite a few different reactions, but a single replacement is where you take a separate element and see if it reacts with a compound. Now, if A is more active than B in this compound, then there will be a replacement where B is kicked out of the compound and A now forms a compound with C. Again, the only way this is possible is if A is more reactive than B. All right, now how would you figure out if A is more reactive than B? You would have to do that by using your activity series. To do so requires a chart that is going to be given to you. If for some reason A is not as reactive as B, even if A tried to come in and kick B out, B would stay with it. So, if B is more reactive than A, then there would be no reaction. So therefore, nothing would happen. You would just simply write as no reaction. Now, we'll get into that with all of our different examples, but this is the basic overall idea. Let's get into it. Starting with this first one, sodium reacts with potassium hydroxide. First, you want to predict the products. So we're looking at sodium and potassium. Sodium versus potassium. Who is more reactive? If you look on your activity series sheet, potassium is actually more active than sodium. So potassium's higher up on the sheet or chart than sodium. So therefore, when sodium comes in and tries to kick out potassium, potassium will say no way. So therefore, no reaction would occur. If we take a look though at the next part, it's magnesium reacts with silver oxide. The two metals are going to battle it out. It's going to be magnesium versus silver oxide. Looking at the activity series chart, it shows that magnesium is actually higher up than silver. So therefore, magnesium is going to come in and kick silver out. So now, silver will be by itself, and magnesium will now be with oxide to form the compound magnesium oxide. Whoops, misspelled my magnesium there. Pardon my cramped writing. Now that we finished out the word equation, let's actually write this out. So, if magnesium's by itself in the chemical equation, it's magnesium, reacts with silver 1 oxide. Now that's an ionic compound. We know silver has a +1 charge and oxygen has a 2- charge. So that means silver 1 oxide is going to be Ag2O. Now it's going to react, and since silver got kicked out, silver is by itself. And magnesium oxide, we have to look at their charges because this is an ionic compound, and they're both +2 and -2, so they become MgO. Now that I've done that, I definitely need to balance it out, and it looks like the only thing unbalanced is my silver, so I'll put a 2 there. But now, a single replacement reaction has occurred. Magnesium kicked silver out, silver's now by itself, and magnesium is now with oxygen. Everything's balanced, and congrats, you've done a single replacement reaction. Checking out number 3, it says calcium reacts with zinc fluoride. Looking on the activity series, it's calcium versus zinc that I'm looking at. It looks like calcium is higher up than zinc on the list. So therefore, this reaction will occur. So that means zinc is going to be kicked out and be put by itself. And calcium will now be with fluoride. So we'll call that new compound calcium fluoride. And let me get rid of that other writing here. All right, so now that we have the word equation finished up, let's start writing out the chemical equation. Calcium is by itself, which is Ca. It reacts with zinc fluoride. Now we know zinc is +2 and fluorine is -1. Coming together is an ionic compound that would be ZnF2. Now zinc is by itself, so it's just Zn. And calcium fluoride, let's see, calcium's +2, fluorine's -1. So therefore, that would come together as CaF2. And in this case, nice enough, everything is already balanced. So we have done our single replacement reaction. Just remember, calcium came in and kicked out zinc. That's why zinc's by itself, and calcium's now with fluoride. Taking a look at question number 4, barium reacts with hydrogen chloride. So that means barium and hydrogen, the two cations, are going to battle it out. And it does appear that barium is more reactive than hydrogen because it's higher up on the list. So therefore, barium will kick out hydrogen. So now we're going to end up with hydrogen by itself plus barium chloride. Once I write out my words equation, now I can start writing out my chemical equation and eventually balancing that out. So let's do that. Barium is by itself. Hydrogen chloride, hydrogen's +1, chlorine's -1. So as an ionic compound, they come together as HCl. Hydrogen's by itself, and did you remember when hydrogen's ever by itself? It's H2. Why? Because of Brinkelhoff. That's right. All 7 of these diatomic molecules are found all alone when they are by themselves in the chemical equation. They are doubled up when they're all alone. All right, barium chloride, not a problem. Let's look at that. Barium is +2 and chlorine is -1, so therefore that's BaCl2. Perfect. Do we need to balance it? Absolutely. 2 hydrogens, 2 chlorines. Let me throw a 2 in there, and now we are balanced. Excellent. Taking a look at number 5 here, magnesium reacts with potassium sulfate. So it's magnesium versus potassium. If you look, though, on the activity series, potassium's higher up than magnesium, so potassium is stronger. So can magnesium come and kick out potassium? No, he cannot. So therefore, there is no reaction. We can't do anything. If you mix those two together, nothing would happen. Let's skip to number 7 here. And if we do tin 4 reacts with aluminum fluoride, tin 4 and aluminum are going against each other. It does, however, seem that on the activity series, aluminum seems to be higher up than tin does. So therefore, aluminum is not going to allow tin to come in and take fluoride. So therefore, there would be no reaction. So you always have to check your activity series first, which should be on your actual sheet already for you to check. All right, looking at number 8 to finish off. Nickel 2 reacts with lead 4 chloride, and it seems that nickel is higher up than lead. So therefore, this reaction is going to occur. Nickel will kick out lead. Lead is now going to be by itself, and nickel will now be partnered up with chloride. All right, so that means if we can write this out, nickel will be by itself, lead 4 chloride, so that's lead 4 plus, that's what the Roman numeral 4 means. Chlorine is -1, so that means you would need 4 chlorines to balance out the lead 4. Lead is now by itself, and nickel chloride, well, nickel has a +2 charge, and chlorine has a -1, so therefore you would get nickel and 2 chlorines. To balance this out, this shouldn't be too tough. You need 4 chlorines, so you put a 2 there and a 2 there to balance everything out, and you should be good. Again, these are single replacement reactions, so the cations can swap out if the original metal that's by itself is stronger than the metal that or cation that is in the ionic compound. Thanks for listening. I hope this makes sense to you, and best of luck with all of your practices. See you later, Chem Fam.